Okay, so in this video, we're going to talk about the different factors that affect or influence how something dissolves or influences solvation. So I want you to imagine you're trying to dissolve sugar in water. Okay, so you have a cup or beaker of water, you're trying to put some sugar in it. Think about what you would do to get that sugar to dissolve faster. Okay, so if your sugar that you have, let's imagine it's not just any sugar, it's a sugar cube. Okay, so what are the types of things that you would do to get that sugar cube to dissolve faster? Well, maybe you'd stir it. Maybe you'd break up the sugar cube into smaller pieces. And you might even think about heating the water up a little bit, if you don't mind what temperature it is, to get the sugar to dissolve faster. So those are actually the three things that affect solvation. So the first thing that we look at is particle size. Okay, big, and when we're talking about particle size, we're thinking about the surface area. So the more surface area that can come into contact with the solvent, the faster that something's going to dissolve, which means that lots of small pieces are going to dissolve faster than one big piece, because the total surface area is going to be more if it's lots of little pieces. Okay, so little pieces are going to dissolve faster than big pieces. We also want to agitate it if we want it to dissolve faster. So those are things typically like stirring. So in science classes, you might add something that's called a stir bar, which is magnetic and spins at the bottom of the beaker. Or if you're thinking like in your kitchen, using a spoon to stir something up, agitation. That helps it dissolve faster. And then changing the temperature can help things dissolve. So if we heat something up, if we heat up this solution, it's going to dissolve faster. Why? Well, particles move faster when they're hot. So if they're moving faster when they're hot, they're going to spread apart more quickly, and therefore they're going to dissolve more quickly. So if you want something to dissolve, you're going to increase the temperature, you're going to stir it, you're going to make sure that it's in small pieces. So those are the things that you can manipulate in order to get something to dissolve. So those are the types of things that we look at when we look at solids dissolving in liquids. We can also have solutions where gases are considered dissolved in liquids. A good example of this is a bottle of soda. Okay, so when you have a bottle of soda and you open it up, you see all the bubbles. What's happening is it's carbon dioxide, so CO2 gas, coming out of solution and leaving. So those are getting undissolved. Okay, they're not evaporating because they're not turning from liquid CO2 to gas CO2. The gas is just leaving the solution and it's separating out and instead of staying mixed in with the soda. So when we're talking about solutions with gases and liquids, you can also change the pressure to get it to dissolve. So if you want to dissolve, if we think about going backwards, if we want the CO2 to dissolve into solution, we're going to pressurize it. So we're going to increase the pressure in the container, has to stay sealed. That's going to force the CO2 into the liquid, and so we call that dissolving the gas into the solution. So the three main things we're going to look at are size, agitation, and temperature. If we're looking at something involving a gas, we're going to factor pressure into it as well.